Our question today is, how do graphs represent motion? And in this tutorial, we're only looking at distance versus time graphs. And what I mean by that is that on the y-axis, the vertical axis, that is going to represent distance. And the horizontal or x-axis will represent the time. Now, the first way that a graph can represent motion is if an object is not moving. When an object is not moving, the line is going to be flat. We can see that if, let's say, we have a distance of 10 meters. At all points, we'll always be at the 10-meter mark. And so in this situation, the line is going to be flat. It'll always be at 10 meters. If the line is going up, that means forward motion. So here we have a pictorial representation of that in this situation. We have the line going up, and so this object would be moving forward, like a car moving forward. If the car is moving in reverse, or moving backwards, then the line is going down. So what this represents here is that the numbers are getting smaller. So maybe I started at a distance of 10, then I go to a distance of 8, then a distance of 6, and so forth. I'm always getting smaller numbers, so I'm going backwards. Now we can also represent a faster or slower speed based on how steep the line is. If the line is steeper, that means that the object is moving faster. So here we see that the blue line represents a fast-moving object, whereas the red line represents a slower-moving object. And that's because the slope of a distance versus time graph is equal to the velocity of the object. Slope is how steep the line is. The steeper the line, the higher the slope, and therefore the faster the velocity. For the last thing that we can really show with a graph is if an object is accelerating. If an object is accelerating, that means that the slope is changing. So we start with a slope where it's flat. So the object is not moving to start. And then the line gets steeper and steeper and steeper. It is speeding up. And so if it's speeding up, it is accelerating. So for an accelerating object, the line is curved. Now, again, to speed up means that it gets steeper. We could also have it so that it's slowing down. And in that situation, it starts as very steep, and then it flattens out. So we could have a speeding up, which would be the red line here, the kind of dotted dashed line at this point, and we could have slowing down, which is the blue line where it flattens out.